Hi, Assalamualaikum to Miss Ita. So today my group and I will present to you for our assessment 2, which is to present on the palm oil production for CHE 323 palm oil manufacturing and application. But firstly, I'm going to introduce our group members for group 4 for EH1105B. So first member is me, which Nurul Dalila Afina binti Anwar, and next one is Arbaenah binti Hamsi, Siti Diyana binti Rahman, Nurul Izah binti Johari, and Muhammad Daniel Haikal bin Nur Azlan. So I'm going to present to you for feed production. Hi and Assalamualaikum. My name is Nurul Dalila Afina binti Anwar and I'm going to share to you on shortening production. But first, I'm going to explain to you on what is shortening. I think most of us not really familiar on what is shortening, as it is not commonly mentioned in any of the recipe in the confectionery making or any baking recipe, as shortening is commonly used in the mass production. However, shortening and margarine is kind of similar, but a little bit different in terms of composition, as shortening is fully or 100% contains of fats and oils, and meanwhile margarine is only contains 80% of fat and oil. However, both are similar in terms of the production, as both are using the cottonseed oil and also palm oil. Okay, and this is due to the both of the oils having a small needle texture light, which will help on producing a smooth texture in the shortening and margarine production, therefore making it a very suitable raw materials in production of shortening and margarine. And moreover, shortening is also mostly used in confectionery and baking, and however it's only focusing or commonly used in certain confectionery bakes, as it has a different texture compared to margarine, therefore making it very specific in terms of material ingredients for production. Okay, so next I'm going to explain to you on the shortening production based on the process flow diagram shown here. Okay, so first it's going to start from the oil supply right here. Okay, so from the oil supply, the oil will be fed into the raw material tank. Okay, so once it's fed into the raw material tank, it will be injected with air and nitrogen. Okay, so it will be ejected right before it's sent to the booster pump. Okay, so the booster pump right here is functioning as maintaining the pressure in the mixture of the air and the oil, so that it's able to retain the constant density between the oil and the air. Okay, and then once it's constant, the mixture of the oil and air will enter the heat exchanger right here. So this is heat exchanger. So in this heat exchanger, the mixture of oil and air will be pre-cooled so that we can minimize or reduce the heat load in the potato air unit. Okay, so the reason why we will be having it pre-cool is to reduce the heat load, and also we will be maximizing the cooling capacity. Okay, so once that's pre-cool, it will enter the A unit. Okay, so once it enters the A unit, it will undergo the process crystallization. Okay, so for the process crystallization, it will undergo in a very low temperature, as we want the mixture to retain its state or to be living. The A unit to enter the worker or the B unit in a semi-fluid state. Okay, so therefore, once it's finished, or once the process is complete, it will be fed into the working unit, or also known as B unit. Okay, so in the B unit, it will undergo the plasticizing. Okay, so in the plasticizing, it will have an increasing temperature due to the specific latent heat of crystallization, which occur or exists due to the process occur in the A unit here. Okay, and it's also due to the endothermic reaction from the mechanical energy which supply the heat input, so therefore making the temperature in the working unit to increase. Okay, and then once the plasticizing to done, it will be fed into the extrusion valve right here. So this extrusion valve right here will help on having the products from the B unit to have a thorough gas dispersion, and also help on um, erasing or removing any crystal aggregates from the A unit and B unit, and it also will help on maintaining the pressure from both A and B units, so that it has a very constant pressure. And once it's done, it will enter the booster pump right here. So this booster pump right here is also known as secondary rotate gear pump. Okay, so the reason why we need this is to increase the pressure so that it able to transport it to the filling point right here. Okay, so once the pressure is increased, it will be transferred into the next extrusion valve right here. Okay, so this extrusion valve right here will help on the final texturization of the products, so that it will be in a best condition, and then it will undergo the packaging. I think that's it. Thank you.
Assalamualaikum, my name is Diyana. So I will be presenting on process involved and equipment used for shortening production. So basically, for the common process used in shortening production is hydrogenation process. So hydrogenation process is a process where liquid state palm oil at room temperature react with hydrogen atom and become solid. And the unsaturated fats and oil will be converted to saturated fats and oil. Um, we use hydrogenation process to improve the flavor stability and to keep the quality of oil in the product. Uh, for manufacturing process of shortening, first step is melting and blending the oil at temperature 60 degrees Celsius to 70 degrees Celsius. And the next step is pre-crystallization in A unit at temperature 17 degrees Celsius to 28 degrees Celsius, where here the blend oil will be crystallized. And next step is crystallization in B unit. So in B unit, the crystallized of blend oil is still continued until it's done and at equivalent temperature. And for the packing, in packing we have variety types of packing depends on its use. And for tempering at temperature 25 degrees Celsius to 30 degrees Celsius, which is on 24 hours. We use tempering to stabilize the shortening. And last step is for shipment, which is the shortening is ready to be shipped out. And last one is equipment used for shortening production. So we use EBM as our equipment, which is in EBM it already have 5 types of equipment. We have storage tank, mixing tank, heat exchanger, plasticizer, and lastly packaging system. So for storage tank, we use storage tank to keep the oil, and in mixing tank, as the name is mixing, so there will be process mixing in the mix the oil in mixing tank. So for crystallizing, it will be in heat exchanger, and plasticizer is for plasticity the shortening, and last one is packaging system, which is to process packaging of shortening happen here in packaging system. And that's all for equipment use and process in shortening production. Thank you.
Assalamualaikum, Miss. My name is Dalila. Today I will talk about the introduction of soap. Okay, what is soap? Soap is actually a combination of fatty acid and lye. Soap is produced when hydrolysis of fatty acid, which is known as saponification. We can add other materials such as color for aesthetic appearance, builder to boost the cleaning, and perfume for a pleasant smell. Then soap is actually a surfactant and emulsifying agent. Emulsifying agents means soap can extract dirt without actually mixed naturally with the water, which is soap is effective to kill germs. Next one, we have type of soap. This is the type of soap that I have choose. Actually, there's many more, but this is the 3 that I choose from the internet. And then first we have glycerin soap. Glycerin soap, we can use it as moisturizer and cosmetic purposes. And then the next one we have transparent soap. Transparent soap is actually a base for soap. We only need to add color, perfume, burger, which I stated at the slide before. And then the last one we have liquid soap. Liquid soap is actually quite difficult to liquid. And then liquid soap is actually normally is for body wash. Okay, next one we have what is the difference between soap and detergent. Okay, soap is, as we know, soap is made from fatty acid and lye, which is fatty acid is a natural ingredient. And then detergent is made from synthetic man-made derivative. Then soap, we need a clear water wash after we apply the soap. Where detergent is free rinsing. Soap actually leave film on the surface of the surface that the soap has been applied if we didn't use clear water to wash it. But detergent does not leave residue if we didn't wash it at all. The common between the soap and detergent only is both of it is surfactant. That's all for me. Thank you.
Next is process involved in soap production. Fractionation process. Fractionation process is a process to separate mixtures of liquids, gases, or solid into their components. In this soap production plant, the refined bleached and deodorized or RBD palm oil was used for the process as a raw material. The RBD palm oil will be preheated up to 70 degrees Celsius by the heater to give a homogeneous mass with no solid portion. The oil then fed continuously into the crystallizers, which condenser to cool the oil. After that, the effluent product from the crystallizers will enter the filtration to undergo a process to separate the palm oil into two fractions, which are liquid fraction, palm oil 65 to 70% with melting point 18 to 20 degrees Celsius, and solid fraction, palm stearin oil 30 to 35% with melting point 48 to 50 degrees Celsius. Then palm olive oil will be collected as the end product in the form of liquid at the room temperature. However, palm stearin oil will be collected as a byproduct in the form of solid at the room temperature. So, there are 6 processes used in this soap manufacturing. Firstly, saponification process. Saponification process is a process of converting the fats or oil into the soap and alcohol by heating them with the presence of aqueous alkali. As you can see the chemical equation which shows the conversion of the palm olive oil into soaps and glycerol by heating it with the presence of lye or sodium hydroxide. The palm olive oil will be fed into the continuous stirred tank reactor or CSTR at temperature 120 degrees Celsius and pressure 200 kilopascal as well as stirring speed at 400 to 1100 rpm together with sodium hydroxide solution to produce glycerol and soaps. The purpose of the mixer is to increase the reaction rate to optimize the yield of soaps. The effluent products, which are soap, glycerol, and lye, will leave the CSTR through the bottom stream. The circulation system ensures a residual level of soap in the autoclave to improve contact between oil and water phases and provides additional mixing. Second is cooling process. The cooling process is a process to remove heat from the processed fluids or solids. The effluent product from the CSTR will be cooled to below 100 degrees Celsius in the cooling mixer by passing it gently across a cooled surface several times. Third process is separation process. The process was meant to separate the neat soap from the solution contains glycerol and lye through gravitational force. In the static separator, the neat soap that is lighter phase compared to the solution was floated to the top of the static separator. This will produce neat soap where 25 to 30% of glycerol and lye have been settling out to the glycerol recovery. Fourth is countercurrent flow process. The neat soap is then washed with a lye and salt solution using countercurrent flow process. The neat soap was fed into the vertical washing column through the bottom of the column while the lye and salt solution was fed from the top of the column. In the column, the less dense neat soap rises while the lye and salt solution flows down to the bottom. This process allows the removal of glycerol more effectively. Fifth process, which also another separation process which happen in the centrifugal separator. The overflowed neat soap from the washing column will flow into the centrifugal separator. This separation was to separate lye from the neat soap. The lye then will be recycled into the top of the washing column. Last but not least, the neutralization process. The neat soap was fed into the steam jacket mixing vessel or crusher to undergo the neutralization process. Neutralization process was carried out to neutralize the remaining caustic or residual alkalinity NaO in the separated neat soap by adding fatty acid. The neat soap then will be recycled and fed to the top of the crusher for additional mixing. Then the neat soap that has been neutralized will be collected to produce the soap bars.
My name is Arbaenah Hamsi and I'm going to explain on equipment used for the soap production. The first equipment is the heater, where the palm oil is preheated first before proceed to the crystallizer. The next equipment is crystallizer, where the crystallization and cooling processes is happen in here, and all part of crystallizer is made from stainless steel. The third equipment is the mixer. In the mixer, it is also contain the stirrer to stir and mix together sodium hydroxide solution and palm olive oil. And then the next equipment is the reactor, and the reactor that is used is a continuous stirred tank reactor or CSTR. And in this reactor also, the color and perfume is added to give the soap color and nice smell. The next equipment is the separator. For separator, static separator and centrifugal separator is used in soap production, and the purpose is to separate lye from the net soap. Next is washing column. In this washing column, it is to remove glycerol more effectively, and since we want the soap only. And the next one is the condenser, where all the cooling process happen during the whole production. It means that all the cooling process during the whole production is happen in a condenser. And the condenser also because we want to make the soap in desirable form. And then the next one is the cutting machine, where the machine is cutting the soap into small pieces so that we can use. And the last one is the drying machine, where the drying and cooling of the soap is happen for the final production, for the marketing. So that's all from me. Thank you.